Preparing for a SQL at Bank of America interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you find the second highest transaction amount for each customer account? I'd solve this with a window function because it is clear and scalable. I would rank transactions using denseRank over each account, ordered by amount descending. Then select rows where rank equals 2. denseRank is useful if multiple transactions share the highest amount, because the next distinct amount becomes rank 2. If the interviewer wants exactly one row, I'd use row number with a deterministic tiebreaker, like transaction timestamp or transaction ID. While answering, focus on window functions, partitioning by account, ordering transaction amounts, handling ties with rank versus denseRank, and filtering the ranked result cleanly. Question 2. How do inner join, left join, and full outer join differ in a bank reconciliation query? In reconciliation, an inner join shows only transactions that match in both systems, such as core banking and card settlement. A left join keeps all bank side records and exposes missing settlement rows as nulls. A full outer join is best when I need exceptions from both sides, bank records missing settlement and settlement records missing bank records. For finance data, I'd never rely only on matched rows because missing records are often the main risk. Make sure to cover matched records, missing records, unmatched debit or credit entries, reconciliation use cases, null handling, and why join choice matters for financial accuracy. Question 3. Write a query to identify customers whose total withdrawals exceeded deposits in the last 30 days. I'd aggregate transactions by customer for the last 30 days and use conditional sums. For example, sum case when type equals withdrawal, then amount, else zero end, compared with sum case when type equals deposit, then amount, else zero end. The filter should use transaction date and exclude pending or reversed entries if the business rule requires posted activity only. Then I'd apply a halving clause to return customers where withdrawals are greater than deposits. In your answer, talk about conditional aggregation, date filters, grouping by customer, transaction type classification, halving clauses, and edge cases like reversals or pending transactions. Question 4. How would you detect duplicate transactions in a payments table? Duplicate detection starts with defining what duplicate means. In payments, I might group by account ID, merchant ID, amount, currency, and transaction date, then count records greater than 1. If exact timestamps differ slightly, I'd use a window function and compare transactions within a small time range. I'd also check status, reversal flags, and external reference IDs. In banking, I prefer conservative detection because false positives are safer than silently double-charging a customer. Be sure to mention business keys, grouping, window functions, exact versus fuzzy duplicates, timestamp tolerance, transaction status, and why duplicate detection is critical in banking systems. Question 5. What is the difference between where and halving, and when would you use each? Where filters rows before grouping, halving filters groups after aggregation. If I want transactions from January only, I use where transaction date in January. If I want customers with more than 10 January transactions, I use group by customer ID and halving count 10. This distinction matters because filtering early reduces data volume and improves performance. A common best practice is to push non-aggregate filters into where whenever possible. While answering, cover execution order, row-level filtering versus group-level filtering, aggregate functions, examples using account balances or transaction counts, and performance considerations. Question 6. How would you calculate a running balance for each account using SQL? A running balance is a cumulative sum over ordered transactions. I'd convert debits and credits into signed amounts, then use sum of signed amounts over partition by account ID, ordered by transaction time and transaction ID. The transaction ID tiebreaker is important because banking systems can have multiple events at the same timestamp. If there is an opening balance, I'd add it to the cumulative sum. This approach is cleaner than self-joins and performs better on large ledgers. Make sure to cover window sum, partition by account, order by transaction time, debit and credit signs, deterministic ordering, and handling same timestamp transactions. Question 7. How do indexes improve SQL query performance? And what indexing strategy would you use for transaction history? Indexes help the database find rows without scanning the whole table. For transaction history, a common composite index is account ID, transaction date, because users often view activity for one account over a date range. If queries also return amount, status, and type, a covering index may reduce table lookups. The trade-off is slower inserts and extra storage, which matters for high-volume banking workloads. I'd index based on actual query patterns, not guesses. In your answer, discuss B-tree indexes, selectivity, composite indexes, read-write trade-offs, common filters like account and date, covering indexes, and avoiding over-indexing. Question 8. Explain ACID properties and why they matter for banking transactions. ACID guarantees reliable database transactions. Atomicity means a transfer fully completes or fully rolls back. Consistency ensures constraints remain valid, such as no invalid account references. Isolation prevents concurrent transactions from corrupting balances. Durability means once committed, the transaction survives failures. In banking, if I debit one account but fail to credit another, that is unacceptable. ACID is the foundation that lets financial systems move money safely under failures and concurrency. Be sure to cover atomicity, consistency, isolation, durability, money movement examples, rollback behavior, concurrency protection, and why partial updates are unacceptable in financial systems. Question 9. What are transaction isolation levels, and which issues do they prevent? Isolation levels control how much one transaction can see from another. Read uncommitted can allow dirty reads. Read committed avoids dirty reads but can still see changed values on repeat reads. Repeatable read protects rows already read, while serializable gives the strongest correctness by making concurrent transactions behave sequentially. In banking, balance updates usually need strong isolation or explicit locking. The trade-off is performance, so I choose based on the risk of inconsistency. While answering, explain dirty reads, non-repeatable reads, phantom reads, read committed, repeatable read, serializable, locking or MVCC, and the balance between consistency and throughput. Question 10. How would you write a query to find customers with suspiciously high transaction frequency? I'd first define the suspicious pattern, such as more than 20 card transactions in 10 minutes. A simple version groups by customer and a time bucket, then filters with having count above the threshold. For rolling windows, I'd use window functions or a self-join on timestamp ranges. I'd also exclude known recurring payments or internal batch jobs. Fraud queries are only useful when the SQL logic reflects realistic business behavior. Make sure to cover time window analysis, group by, count, thresholds, window functions, customer segmentation, excluding known batch activity, and practical fraud monitoring considerations. Question 11. What is the difference between a CTE, a subquery, and a temporary table? A subquery is embedded inside another query and works well for small logic. A CTE names an intermediate result, making complex reporting queries easier to read, especially with multiple stages like filtering posted transactions, aggregating balances, and ranking accounts. A temporary table stores intermediate results for a session and can be indexed, which helps when reused many times. I'd start with CTEs for clarity, then move to temp tables if performance or reuse justifies it. In your answer, compare readability, reuse, materialization behavior, optimization, session scope, performance trade-offs, and examples involving multi-step financial reporting queries. Question 12. How would you optimize a slow SQL query used in a daily risk report? I'd start by checking the execution plan, not guessing. I'd look for full table scans, expensive joins, missing indexes, bad estimates, and large sorts. Then I'd verify whether filters are selective and whether date predicates allow partition pruning. I'd avoid wrapping indexed columns in functions, because that can block index usage. For a daily risk report, I'd also consider pre-aggregated tables or materialized views if the same calculations run repeatedly. Be sure to mention execution plans, indexing filter selectivity, avoiding functions on indexed columns, reducing joins, aggregation strategy, statistics, partition pruning, and testing changes safely. Question 13. How would you handle null values when calculating customer balances or reporting totals? Null means unknown or missing, not zero. In balance calculations, I'd use coalesce only when the business meaning supports it, such as treating missing fee amounts as zero. Aggregates like sum ignore nulls, but expressions such as amount plus fee can become null if fee is null. After left joins, I'd carefully distinguish no matching record from a real zero value. In financial reporting, careless null handling can quietly distort totals. While answering, cover coalesce, aggregate behavior with nulls, outer joins, missing versus zero values, reporting correctness, and how null handling affects financial interpretation. Question 14. What is normalization, and when might denormalization be acceptable in a banking data model? Normalization organizes data to reduce duplication and prevent update anomalies. For example, customer details should not be repeated in every transaction row. Transactions should reference a customer or account key. In core banking systems, normalization supports integrity and auditability. Denormalization can be acceptable in analytics or reporting layers where speed matters, such as a customer profitability dashboard. I'd keep the system of record normalized and denormalized downstream with clear data lineage. Make sure to cover reducing redundancy, referential integrity, normal forms, update anomalies, reporting performance, auditability, dimensional models, and controlled denormalization for analytics. Question 15. How would you compare end-of-day balances between two systems and return mismatches? I'd aggregate each system to account ID, business date, and currency, then full outer join those summaries. Coalesce helps show keys even when one side is missing. The mismatch condition would check missing rows or an absolute balance difference greater than an allowed tolerance. I'd include both balances, difference amount, source status, and timestamp in the output. For Bank of America-style financial data, the result must be explainable, auditable, and easy for operations teams to investigate. In your answer, discuss aggregation by account and date, full outer join, coalesce, tolerance thresholds, missing accounts, currency handling, and audit-friendly exception output. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.